Here we're asked to state the degree and determine all the roots of p of x. So degree, what I usually like to say is like how many x's are there going to be when it's all factored out and everything. And this one here looks like we have a single x here and then an x squared here. So if I multiplied all that together, my highest exponent would be x to the power of 3. So I'm going to call this a third degree polynomial. And so I'm going to get 3 roots. Now, my first root is just x equals -4, because that's what makes the whole equation 0. Now, this last part, I need to set this equal to 0 also. And I could try to factor it, but I'd see here pretty quickly that, 2 times 5, 100. Nothing, multiplies to 100x squared that adds to 4x. So I can't factor it. So the next thing I could try is solving with the quadratic formula. So x equals -b plus or minus square root of b squared minus 4 times a. This is going to be the big number all over 2 times a. And now I just got to simplify this. So as I'm reaching my final steps here, one thing to add in here, I did, when I was looking through trying to simplify -384, the square root of that, I just kind of searched for things that multiplied into it. I ended up finding 64 times 6, and 64 is 8 times 8. So I pulled the 8 out. I also pulled out the negative and said and then I can't simplify the square root of 6 anymore. So my final step here is to simplify all the whole numbers because they are all divisible by 2. Then I'm going to get my final answer of -2 plus or minus 4i times the square root of 6 over 5. Now, some people write this all differently, like wherever they place the I and all that jazz. I'm not super picky about it, so I'm going to go ahead and leave it like this as my second and third answer or root. Remember, my first answer was -4. Then I have -2 plus 4i root 6 over 5 and -2 minus 4i root 6 over 5. So third degree gives me 3 answers.